Mercury is the least explored planet in our inner solar system. So let's take a closer look. BepiColombo is a two-spacecraft mission to the planet Mercury. It was developed by the European Space Agency and the Japan Aerospace Exploration Agency. The first mission to Mercury was NASA's Messenger mission, which arrived at Mercury in 2011. Prior to that, NASA's Mariner 10 mission in the 1970s did a few flybys of the planet but didn't go into orbit.
The craft completed a trio of flybys past Mercury. Across the span of its mission, Mariner 10 mapped about half of the planet's surface and even detected a faint atmosphere.
A flyby of a planet like Mercury, it's only a snapshot of that moment that the spacecraft is going past. So it can tend to be incomplete, it's still valuable, but going into orbit around a planet like Mercury allows for a much fuller picture of the planet. BepiColombo will build on data that was collected from NASA's Messenger mission and also from Mariner 10. It will look to answer some of the questions that those missions brought up, and it will likely lead to some answers, but also probably more questions. BepiColombo launched from French Guiana on an Ariane 5 rocket in October of 2018. The journey to Mercury is a long one. It's about 7 years from launch to arrival. Mercury is very difficult to get to because it's the closest planet to the sun. So the gravitational pull of the sun is bigger than the gravitational pull of Mercury because Mercury is so small in comparison to the sun, so its gravitational pull is much weaker. Paradoxically, you actually have to slow a spacecraft down in order to safely orbit Mercury. So if you're going too fast, Mercury won't pull you in. Whereas if you manage to slow down to the right velocity, then you can be essentially captured into Mercury's orbit. BepiColombo will use a number of techniques to reach Mercury. One of the main ones is through a series of gravity assists. Gravity assists are when a spacecraft uses the gravitational pull of a planet to change its velocity and change its trajectory. BepiColombo launched in 2018, and since then it's gone back around Earth 1 time, and it's been around Venus 2 times, and Mercury 6 times. And each of these gravity assists is altering slightly the trajectory and also helping to slow the spacecraft down. But it doesn't help enough. BepiColombo is also fitted with 4 solar electric ion thrusters, which effectively act as a brake. It's been on its journey since October 2018. Everything has gone to plan until April of 2024. Engineers noticed that the thrusters were not operating at full power capacity. When it was investigated, it was realized that they were going to have to operate the rest of the mission with the thrusters at less than full capacity. This meant that it's going to take an extra 11 months to get to Mercury. So instead of arriving in December 2025 as planned, the spacecrafts will arrive at Mercury in November 2026. On its journey to Mercury, BepiColombo will travel in a stacked formation with the Mercury transport module on the bottom. In the middle is the European orbiter, which is the Mercury Planetary orbiter, and on top is the Japanese orbiter, which is the Mercury Magnetospheric orbiter. So once BepiColombo arrives at Mercury, that's when the 2 spacecraft will separate and go into their separate orbits around Mercury. The 2 spacecraft are going to be looking at Mercury's magnetic field. That's the Japanese orbiter will be looking at that. And the European orbiter will be looking at the interior and the composition of the planet. Because it's the closest planet to the sun, it has a really interesting interaction with solar wind and solar storms and its own magnetic field. This kind of extreme dynamic is really interesting for scientists to study because it's going to help us to better understand how solar wind and solar storms impact our own magnetic field on Earth. Temperatures up to 400 degrees Celsius and also minus 190 degrees Celsius. Rigorous testing has to be done prior to launch to ensure the success of the mission and the success of the spacecraft. Here in our new space gallery, we have the BepiColombo structural thermal model. Let's go take a look. The BepiColombo structural thermal model is a one-to-one scale model of the final flight model, but it is designed solely to test the extreme vibrations and incredibly loud noise at launch. And so it is tested on a multi-shaker, which shakes it in all directions to help mimic this. After that, each of the individual pieces were tested in the large space simulator, which is where the extreme temperatures are mimicked to try and ensure the spacecraft can stay warm enough, but also cool enough depending on the environment. I'm going to break it down into a number of sections. At the very bottom, you can see the lower handling adapter, which is how BepiColombo attaches to the inside of the rocket at launch, and that stays on the rocket when BepiColombo is released from the payload-fairing doors of the rocket. So on the Mercury transfer module, which is the module that will deliver the spacecraft to Mercury, you can see on the right-hand side that there is a solar panel. It's folded up, but unfolded, it is 12 meters long. And for the flight model, there's actually two of these. Now on our model, we just have one because they only needed to test one. But on the flight model, there's two 12-meter long solar panels, which power the spacecraft on its journey to Mercury. So next in our stack is the Mercury Planetary Orbiter, which is the European Space Agency's orbiter, which will look at the interior and composition of the planet. On one side, it's equipped with a radiator, which takes any heat buildup from inside the spacecraft and radiates it out into deep space to help keep the internal instruments a nice cool temperature. Additionally, you can see this open bit here where you can see a lot of the internals of the spacecraft. Normally, on the flight model, this would be completely covered. They've been revealed for visitors so that they can see some of the internal workings of the spacecraft. Additionally, you can see up here, we also have this antenna, which looks a bit like a satellite dish, and this is the bit that's incredibly important to be able to communicate all of this data that the orbiter is collecting during its scientific mission and sending it back to the Deep Space Network for scientists to analyze. Hopefully by now you get a sense of the scale of this spacecraft because up at the very, very top is the sun shield. It looks a bit like an Elizabethan collar, and that sun shield is there to protect the Japanese orbiter, which is going to be looking at the magnetic field of Mercury and seeing how it interacts with solar wind and solar storms. So here you can see that the full spacecraft is covered in a kind of silvery material, and that is the multi-layer insulation blanket, or the MLI. And that is a critical piece of equipment for BepiColombo because it really protects the instruments from the intense heat, but also the intense cold of space. Now, this insulation blanket that you can see here on our structural thermal model is not actually the same as the one that's traveled on the flight model. This model was tested and it actually failed. It was not strong enough to withstand the heat and the cold from space. And so the team of engineers had to try and figure out how to improve on it. And if you can see here, there are some gray panels just on the bottom of the transfer module behind me. And that was when it failed, they added an additional layer to see if that would make any difference. And it also didn't work. But they worked through the problem, and what they ended up with was 97 different layers made up of aluminium, plastic, and glass ceramic to make up what ended up being the multi-layer insulation blanket. They also had to make sure that it wasn't too heavy, and so there was extra weight was actually allocated to the MLI, because that was the only way that the spacecraft could withstand the intense extreme in temperatures on its journey to Mercury. And I think this kind of message of failure on your way to success is incredibly important, and one that we want to shout about in this gallery. We have a number of prototypes and engineering models on display here, all of which are a kind of testament to the work and the grit that goes into making missions like BepiColombo a success. If you like this video, why not like and subscribe?